There's ordinary glass. So next we have a polarizing materials. I'll write it. What are polarizing materials? Like which will polarize the light. Naturally available are tourmaline crystal, tourmaline, quartz, Nichols prism, and we have artificial also. The what you can say the polymers, no. So using that weapon, artificial polarizers also. These are natural available. Tourmaline, quartz crystal, nickel prism crystal. So these are the crystals which are available. When you pass a light through them, the light will get polarized. What do you mean by polarized? So suppose say unpolarized light is there. And this is a polarizer. Polarizer, say what we used earlier, the same thing. There's a polarizer. There's a pass axis. Pass axis, let me give the red color. There's a pass axis. Then the light will come with a vibration. So these are the so there's a pass axis. So this particular quartz crystal, let me take quartz crystal. So what it does, it will permit the light, it will permit the E bar to vibrate only along y-axis, and any E bar which is vibrating along z-axis will be absorbed by the atoms. So this, what is this? This is a quartz crystal. This is a pass axis, quartz crystal, or it is also called as polarizer. So it will not permit, actually E bar, what is E bar? E bar initially, let's start with along pass axis. Then E bar will not be there, will not keep quiet, no, it will be continuously should rotate. So as it starts rotating, any direction other than along pass axis, it will block it. So therefore definitely open this particular thing, it will block. Sir, you can say that you said it will rotate in 360 degrees, but you're showing only Y, and then the resultant I'm trying to show. The resultant of E bar is what I'm trying to show it. The resultant of E bar along y-axis and z-axis, because it is rotating YZ plane, no, there's a representation. So what, it will not permit the vibrations along the axis. It will permit only vibrations along y-axis. So the light which is coming out through the polarizer, it will contain E bar vector which will be vibrating only along y-axis. So in fact, what is this? E bar and B bar will be rotating in YZ plane. The x-axis will take it. After it passing through it, what happened? The E bar is made to only vibrate along y-axis. So I'll write the coordinate axis. It'll be easy for you. So what is this? Unpolarized light. This is a linearly polarized light. This one. Here what happened? E bar and B bar vectors will be rotating in YZ plane. Okay. Now what this polarizer will do? E bar B bar vector, sorry, E bar vector is made to vibrate only along y-axis, and B bar vector is made to vibrate. See, both E bar and B bar electric and magnetic field both will get polarized, since we are interested only the light, no, because we are interested only in the vision, and the human eye will respond for E bar vector. That's why the B bar vector we didn't bother. That's why in the books they didn't discuss the B bar vector. Doesn't mean that B bar vector not polarized. E bar and B bar vector both got polarized here. So finally, this polarizer, what it is doing, it is permitting the E bar to it will make the E bar vector to vibrate only along y-axis, and the B bar vector only along z axis. So the atoms let's not go for the molecular level. So that will not be because again, actually what happened, they will absorb they'll absorb the radiation, the atoms will start vibrating again. Any charge particle, if it accelerates, should generate EM wave. Then it will generate EM wave, which will be only along y-axis. There's a one inside phenomena there. Since we don't have a concept of generation of EM wave, no, that's why I'm trying to avoid that discussion. Let's discuss like a story that's all here. So in books, they didn't bother to mention anything B bar vector. Doesn't mean that B bar vector is not polarized. B bar vector also polarized. And at all time, E bar vector should be perpendicular to B bar. If E bar is made to vibrate only along y-axis, how B bar should be aligned along z-axis. Okay, got this. So this is called like a linearly polarized light. We'll do that one. We have a course naturally available, tourmaline, quartz crystal available. So with the help of that open, I can make the light to undergo polarization like this. Now, this plane of vibration, then plane of polarization, two words are there, which are very important. So what do you mean by plane of vibration, plane of polarization? Plane of vibration is what? XY plane. And the plane of polarization is what? So we can take that to XZ plane. So I'll write here only. XY plane. So this XY plane is called as plane of vibration. Then this XZ plane is called as plane of polarization. So finally, what we are doing, half of the energy of the light will be absorbed, no? Half of the energy of the light, because it is made to confine in a in YZ plane, it was vibrating. Then we have made it to vibrate only along y-axis. So therefore, if the intensity of this was earlier I naught, now how much it will become? I naught by 2. So when unpolarized light, if it is polarized, what will happen to intensity? Will reduce by half. Okay, got the idea? This one. So I don't know what will happen to the some of the books, no? So very funny. You should also not laugh. The polarizer, when unpolarized light passes through the polarizer, the magnetic field is removed and the electric field is retained. Since magnetic field is removed, no, so therefore energy will become off. Not like magnetic field is removed. Earlier the electric field was confined in YZ plane. Now it is like a made to vibrate only along y-axis. So therefore the intensity will become off. The same thing also magnetic field also. Earlier the magnetic field was rotating in YZ plane. Now it is made to rotate only along that axis. So therefore the intensity becomes. So if you look at the SU Verma, yeah, just put like this here. If the resultant intensity, if it is vibrating along in y-axis and z-axis, if I remove this, the energy will become off. So when an unpolarized light passes through a polarizer and gets polarized, then what we can say that one, the intensity will become off. Off of the energy will be taken out. So the energy flowing per unit area per unit time will become intensity. Then we have vertical polarization, horizontal polarization. What do you mean by that? It all depends upon how the path axis is aligned, no? If the path axis is along y-axis, so shall I say it is vertically polarized, it is made to vibrate only along y-axis. If the path axis is along z-axis, then the E bar vector is made only to vibrate along that. Then it's called a horizontally polarized here. We have even elliptical polarizers, circular polarizers, because this E bar vector, it will rotate like this, no, anti-clockwise. Now we have clockwise, anti-clockwise polarizers, circular polarizers also. They're not part of syllabus. Let's confine only for the linear polarization, not circular polarization. Now this is also called as vertically polarized here. Linearly polarized, or you can select this is a vertically polarized. If pass axis is if the quartz crystal is there, no, I'll align in such a way that the pass axis is along z axis. In that case, what will happen? It will become horizontally polarized here. Okay, I'll try to, okay, we'll have a diagram, small diagram. This is x-axis, y-axis, z-axis. So this is a pass axis. Now again the same thing. I'll choose the green color, green, and the dots below. So this unpolarized light is coming. Next, one more diagram. Very easy chapter, and one question every time it is coming. And then any student what happen will be able to score in exams, because there won't be anything to ask anything very difficult thing here. Z-axis, no? So Z-axis will show like this. Yeah. And now if I orient the Polaroid, I think, okay, fine. So there's a pass axis. Unpolarized light. So okay, you see this. This is the unpolarized light. This vertically polarized light. What is first? Let me write first time. No, vertically polarized VPL. This is horizontally HPL. Both are linearly polarized. We'll call them both as linearly polarized here. And there's a quartz crystal or tourmaline, or artificially manufactured polarities. Anything. So this called like a polarite. Intensity how much? I naught. It is I naught by 2. Okay, there's a way in the basic idea of the polarization. Anybody having doubt, you can ask me. Then I'll proceed to the next two concepts are there. We'll finish off this chapter. Let me have water. Okay, completed. So you may ask like, sir, I'll stand here. Do I see anything polarization? Means, will I see that E bar vibrating along y-axis? Sir, now I'm seeing E bar vibrating along z-axis. Nothing. No, you don't see anything. What you can notice is only the intensity of light. Only you can see the difference in intensity of light. Beyond that, nothing. So to really, because see, okay, finally we are the observers. No, we wanted to notice this polarization. Just with one Polaroid, I cannot notice even the intensity decreases. Okay, that's all finished. Beyond that, nothing. Still, we can say that okay, polarization intensity got decreased. Suppose the tube light is there, you put 100 watt, 50 watt. Do you really see notice? Not that much, no. 100 watt, 50 watt. Two bulbs you keep it, switch on 100 watt. Next switch on 50 watt. Yes, you can just notice the intensity variation. That's all. But you can't say that is it vertically polarized or horizontally polarized. Nothing. That's not possible because can we sense the E bar vector? Okay, now the light is entering into your eye. Sir, E bar vector is entering into my in this direction. Nothing. Got the idea? This one. So to study further, let me bring two polarites. Then it become very easy for me. For that open, I'm going to introduce a Malus law. In the end, we'll just discuss why this polarization is so important. Is it really that useful to be worth studying?